Hello guys, see this situation from last time? We basically need to visually check which one of these is a winner. And that is kind of bad because we are not that precise. So the question is how to do that thing programmatically. Because the whole purpose of programming is to pass jobs to machine, so we don't need to think. Okay, so we are forgetting about visual checks, visual confirmation, and we're going to devise some kind of, let's say, algorithm. So if you're thinking that that algorithm need to be complicated, like some collision detection with a target which is actually a circle, then you're wrong. Why? Because here, to tell turtle state, we have very nice position method on that specific turtle that will return x and y coordinate for us, so we can do all kind of manipulation and checking and stuff like that. So let's first print position of turtle 1 just to practice, and then a little bit later we're gonna devise that like a check or algorithm. Algorithm, very simple one. Right, so the target will be turtle 1, and we're going to use position method, and of course this method you don't need to pass any kind of arguments to it, because this stuff will just return result to you, so no arguments. Okay, so save and F5, and nothing's gonna happen here like in this part of a shell, because we are not doing anything with the data that we have at our disposal. So let's use it, well, at least through simple printing. And now we will get those coordinates. F5, and you will see a lot of numbers here. Hopefully. There you go. So the question is how to check these things. Okay, let's answer that question, but first I'm gonna lower down the size of these turtles, because it's easier to work with smaller objects when you are messing around with coordinates. Well, this is at least what I think about that. And sure, of course, you can also check position for turtle number 2 or any other turtle you have on the screen, if you have 5 or 6 of them, if you have bigger game. Right, so I will not delete this size of turtles, I will just, pull it off this service with comments, one-liners. So let's check that, and now we will have a lot of automatic positions on the screen for both of these guys. There you go. Okay, scary stuff, but don't worry too much, because you just need to care about 1 pixel. Here, the starting point of your target, which is basically circle. So you don't need to check for every pixel on this imaginary line. Just this 1 pixel is enough to tell you the state of winners here for both of these. So don't worry about that. Right. So the question is, well, what is that pixel? So see this stuff? This is starting point of our circles, like beginning of coordinate system for that target. So we actually have our target. So when we check against 300, we will have a winner. Okay, so let's do that down there. We're gonna do that with if statement, like if T1 position equals to 300, then we are going to do something, but it will be very nice if we put this into dedicated brackets, because it's easier on eyes. Well, at least that's what I think. And the problem here will be, well, let me explain. If position is 300, then we are going to print like turtle 1 wins. 1 wins. But actually we are creating error here, so let me explain what's gonna happen. So we will have smaller like turtles, but we will not get usable result, guys, because we are checking about both of these coordinates. This thing will return us x and y, but what we need is just y. So how to get that y? Well, here we are going to use positions, basically angle brackets. So when you say angle brackets, that means you can extract those positions, and x will be position 0 and y will be at position 1. So when you say 1, then you are actually checking against vertical coordinate. And let's run this stuff and let's see what's up. and this will be very slow, but guys, maybe we will get correct result or maybe not, and I'm going to explain why. Let me just see what's gonna happen. Maybe we'll get it, maybe not. Here. So yeah, turtle 1 wins, but here's a problem. See these like steps here? We're talking about from 0 to 3 steps. So this 300 equals to exactly 300 will work only if you are moving your turtles by 1 pixel. But when you do that, you don't have that element of randomness. So basically you are destroying the whole purpose of your game. So you must have some bigger number here from 1, because you need that randomness. So how to solve that thing? Well, here you will not check against 300 exactly, you're gonna check against 300 and more, because our steps here, pixel steps, can be smaller or bigger randomly. So there is a chance that we are going to miss that 300. So how to do that? Well, we are just going to say more or equal to 300. And it will be very nice if we do the same check for turtle number 2. So let me copy paste a little bit. I'm gonna grab this and I'm gonna put it down there, and we're gonna use elif in this case, and we are checking for turtle 2 here, and result must be turtle 2 wins. So let me see, will that work? And this is kind of slow, so I need a bigger steps here. Like we're gonna use 10 possible jumps, so the jumps will be random up till 10, so the turtle will be faster. Turtles, hopefully. Okay, they are faster, but let me see. Okay, so turtle 2 wins and they are off the screen, and then turtle 1. So this will not work. So what we need to do here is, when turtle 1 wins, we will break, and when turtle 2 wins, we will also break from execution. So let me see, will this work? Probably it will. Hopefully. Okay, turtle 2 wins. So this is nice, and let me find situation for turtle 1, for a red one, hopefully. Alright, no, why the turtle 2 wins? Well, is it really winning? Oh, I can't do zoom this. Oh yeah, it is winning. So the spaces between arm of turtle and for a red one is smaller than this space. Right, so turtle 2 definitely wins. I need to confirm result, correct result, a visual for turtle 1 to make sure that everything is cool. Okay, yeah, that's it. So everything works. But I need to make sure, so at least one more time. Come on. Yeah, that's it, we have solution. So that's it, guys. This is how in couple of lines of code, in 6 lines of code, you have solution to answer to question who is winning here. And of course, if you have like a bigger number of turtles, then you can use some kind of like a list for all these turtles, because manually typing T1, T2, T3 is kinda, well, boring. So you can devise this source to be a little bit complicated with some kind of automation and automatization, how to say this in English. Anyway, guys, now you have extremely nice base to play with more turtles if you like. And I don't want to go to like more turtles than 2, because the source code will be big. And if this is the first time for you watching these tutorials, then up till now I have 11 tutorials that you can check, and then if you don't understand this, after 11 tutorials you will be able to grasp the code. And don't worry, guys, if this is your first time, this is just a turtle model, so it is very nice to grasp all kind of movement in Python modules, well, at least in graphical one, and that will be extremely helpful a little bit later when you start with some kind of serious game development, let's say. Right, I'm gonna shut up, and as always, thank you for watching, and see you next tutorial.